So with the toggle node, it's essentially a way to extend a condition forward in time, right? So there's multiple ways to extend a condition forward in time. And so what's a condition, right? Well, that's what solver nodes are for, right? That's what all these nodes are, right? They're conditions, right? A crossover is a condition, right? The slope of an indicator is a condition. The threshold level, is the CCI above 100, or is the CCI above 200, below negative 200, right? Those are conditions, right? And so what if you need to take that indicator condition and extend it forward in time, right? Well, so that way the next condition can occur, right? So you're taking one indicator condition, that happens first in time, and then a few bars later, right, another indicator condition happens, and you want to link those two conditions together and build your signal. So so the toggle node is one of those things. The other common way of doing that would be the signal extender. All right. So the difference here between the signal extender and the toggle node is the signal extender is limited to X number of bars, right? So it has a limited lifespan of extending for, right? And that's per the bar count here, right? So sometimes you don't want to limit that. You just want it to go, and instead you would use another condition to turn off that extension of the signal, right? So you can see the toggle node has an input and a reset, and then on the menu you have various options here, right? So you have on signal. So does the input turn the toggle node on, and does the opposite signal, so if a long signal comes in, right, it'll turn the long side of the toggle node on, and then if a short signal comes in, right, then it'll turn that long side off. And I'll give you guys a physical example here in a moment, right? And then you can also use resets here as well to control various actions, right? So with two inputs and having an on signal and a on opposite signal, right? You have a lot of flexibilities to be able to turn this toggle node on and off. So to give a simple explanation here, I'm just going to build a simple 930 crossover here, so we have some signals to work with. So let me pull in a crossover signal here. All right, I'll just give it a quick simple name, and I'm just going to use the SMA. There we go. All right, change the SMA to a 9 period. Call it good. And again, and 30 period. There we go. All right, so we now have some signals when these two moving averages cross over each other. So if I connect that in to the toggle node, right, and this is with the default settings of the toggle node, right? So on signal is force on, and then when an opposite signal comes in, it turns, right? It turns whatever long or short side turns it off, like so, right? So there we go. So this also is kind of a simple way to, right, to where if you have a single, right, signal here or a single output, right? So, the term signal is used very loosely here, right? So this doesn't have to necessarily be a trade signal, right? So things going into the toggle node aren't trade signals, at least not yet, right? Usually after the toggle node, you'll have some filtering and everything, and then it becomes a trade signal. But what what's going into the toggle node from this crossover, right, are these crossover signals here, right? So we have this one long, right, and then we have a short. And so if we look at the toggle node, right, we can see the toggle node kind of fills in, takes this long signal and fills in and gives you a continuous long output down here. And then when a short crossover occurs, right, then it flip-flops, right? That's just the default basic mode there, right? So now what we could do here, showing some of the other modes here, is we could put this in toggle mode like so, right? So now the on signal, so when a signal comes in, and the on opposite, it's just going to toggle the node on and off here. And yeah, so there we go. We can see it's toggling on and off here. And let's see, what is initiating it? So yeah, so it looks like a cross down is toggling it on, and then a cross up is toggling it off, right? So in toggle mode, well, at least with this setup right here, it's whatever the first crossover signal is at the beginning of your chart, right? So we have to go all the way to the beginning of the chart, and we can see, yeah, so the first crossover signal is a cross down. So the cross down is what ended up being the first one that turns the toggle node on, right? And so then all the cross ups are turning it off there. Right. So let's see here. Let's, yeah, let me provide probably another more practical use here for the toggle node, right? So the toggle node can be used to kill signals for the remainder of the day here. All right. So yeah, so give me a moment here to set this up here, and I'll give you an example of how, yeah, you can use the toggle node to prevent signals for the remainder of the day here. And again, I'm just going to stick with my little crossover signals, but I'm also going to filter my crossover signals here. So that way we're only seeing these crossover signals during RTH. There. All right, so let me load in the RTH session. There we go. All right. And then next, connect this together. All right, so let's take a look at what we have. And let's go back to the beginning here of the chart. There. All right, so there's our signals. All right. And so now, right, we only see signals during RTH there. So there's no signals in the overnight session there. All right. So let's say, right, we only wanted to see the first crossover signal. And I guess this would more practically be used with an opening range breakout system here, but I don't want to take the time to build an opening range breakout here, right? You know, again, this lesson here is for the toggle node here. So I'm just going to stick with the simple crossover as my signal source here. So, all right, so let's connect that in like so. All right. So, all right. So once we get to the RTH, right, it's right. Toggle node right now is going to be flip-flopping, but again, we're going to adjust the settings here so that it actually kills all the signals here. And let's see here. I do need a couple of more things here. So I do need to set the input on signal and opposite signal. I need to set both of those to force on, right? And then also, right, so if we're going to reset the toggle node at basically the end of the day, I need another time session solver to identify that time of day there. And all right, yeah, so I'm just gonna create a 1 hour block of time here. Like so. And let's go back to yesterday. There we go. All right. So there's our block of time, right? And so this is during the overnight period, right? The extended trading period there. And there you go. I'll just call it a 1 hour end of day signal. So the toggle node, right now, right, once it gets flipped on, right, so if we go back to the beginning here, right, it gets flipped on and it stays on permanently, right? Because if we look at the toggle node settings, all we have is force on, right? And there's nothing turning it off. So the toggle node will never turn off there. So we're going to use this end of day signal here connected into the reset, and now we'll use the resets here to turn the toggle node off, like so. So now let's kind of scroll through here. All right, so here's the RTH period, and there we go. Now toggle node gets turned off, like so. There. And let's go to the next day. All right, so here we are. I believe we're actually on the current day. Are we not? Let me see how many days I have loaded on my chart. Okay, I do have a couple of days. Okay, great. Because I'm using the toggle node to allow the first signal through, actually, I do need to flip all of these settings here. I'm going to reverse them all. Because in this case, I'm not actually taking a signal and extending it forward. Yeah, so for this example, we're using the toggle node to limit the number of signals there. So this is, yeah, a bit of a, atypical situation here for the toggle node. And let's see here. All right, so I need one more AND node here. Like so. And then also I need a delay mechanism here. So what's happening, right, is our signals, when our signals are coming in here, and let's actually take a quick look and let me mark it. Right, there we go. So the first signal of the day, right, is that short cross down. And then I'll just mark another one there. So there's the second signal there, right? Now, if we look at the toggle node, right, let's focus in on this bar, right, we can see when the cross down signal comes in, it turns the toggle node off on that signal bar. So I need to delay this by 1 bar here. So I'm going to grab a look back node. And if we look at the signal from the look back node, right, remember I put the arrows on here. So now we can see the signals are shifted forward by 1. Right, 1 bar there. So yeah, so I'm using the displacement function here. So let's name this. There we go. So we know that all this look back node is doing is it's just displacing the signal by 1, right? Shifting it forward there. And now I'll use that, plug that into the toggle node. So now let's look at the toggle node. All right. So now the toggle node is actually on for when the first signal comes in. So now, if we look at this, there we go. There is our first signal of the day, and all the other crossover signals are now gone, right? Are now gone. Now, let's take a look at the toggle node here. And so once we get to, right, the overnight session, our little time-based reset here turns the toggle node back on. So our toggle node is now on during the overnight session until we get to the next morning here. And let's keep going. There we go. All right, so here's the next morning. And let's take a look at the signals coming in. It looks like another short again. Starts the morning off. There we go. Let's mark it. And then I'll mark the second signal. There we go. Right. And so again, if we look at the toggle node, you can see, right, the toggle node was turned on, right, until we get to the first signal. And then the first signal comes in and turns the toggle node off, right? So again, remember, so the resets here are turning the toggle node on overnight. And then when the actual, quote, trade signals come in, right, and those are coming into the input connection. And if we look here, right, the input connection are turning the toggle node off. And then if we look at the actual signal there, so let's see here. I'm just going to name these AND nodes so we kind of know what's coming out of them. There we go. All right. So yeah, so picking up here, so this AND node again, right, shows us the first signal, and because again, just to re-emphasize here, right, the crossover signals coming in to the input connection, right, and I have the input connection set to force off, right? So once that first signal comes in, it turns our signal node, our toggle node off, and then all the other crossover signals now can't get through because the toggle node is turned off. And then with this AND node, right, with the toggle node off, that means no other signals get through this AND node. There. All right. Yeah, so there you go. First signal, and then all the other crossover signals there don't get through for the remainder of the day. Right. Yeah. So the toggle node is really just a combination of turning it on and turning it off with various conditions. All right. As you see fit. So that so I think, yeah, it's safe to say that this toggle node is used in a little more complex systems here. So and with the toggle node, let's kind of go into the actual settings here, right? Actually, let me just add another one here. All right, so again, let's take a look at the default settings, which is when a signal comes in, it's defaulted to turn on, right? And then when an opposite signal comes in, it turns off there, as shown for, originally shown. But you have all of these options here, right? Force on, force off, toggle, right? So toggle just automatically flips. So a signal comes in, turns it on. The next signal comes in, turns it off there, right? And then there's no action here, right? So we can see the resets here are set to no action there. So, with the two inputs, and either you're reading the signal coming in or you're reading the opposite signal, right? And what is opposite? Opposite of what? Well, it's whatever state the toggle node is in. So let's connect this, connect that into the input here. Actually, yeah, take it from there. And let's go back here. There we go. And so our first signal, right, it's a cross down. And so that turns the toggle node on. There. Right? And so what's forced on is the short signals here. So what will turn these short signals off, right? So the current state is short for the toggle node. And so the opposite signal would be a long signal, right? So it all depends on what the current state is of the toggle node. So once a long signal comes in, right? So we have a long cross up, right? So this long signal is the opposite of the current state, which is short, right? And so now the toggle node is in a long state. And so what would be the opposite signal now? Well, now it's a short signal, right? Or a short cross down in this situation here. So the short signal coming in is now opposite of the long state that the toggle node is in. So, right. Yeah, let's see here. Now, here, yeah, I'm going to, right, use my end of day little timer node here, connect it into the reset here, and then on the reset, I'll set both of these to force off here. All right. So when we get to the end of the day, and right, so there we go. So the last signal was a cross up, and then we get to the end of the day, and the toggle node is turned off. So in this situation, right, our toggle node is off during the overnight session here until we get to the next morning. There we go. There. Right? And then the toggle node gets turned on again when the first signal comes in there. And again, right, and that's because right, we're feeding this AND node, right, which our crossovers are filtered by this RTH session here. Right? Yeah. Yeah, so just to re-emphasize, right, the toggle node is useful when you're trying to connect one condition, right, one indicator condition to another indicator condition, when a signal extender doesn't quite work out, right? So sometimes, there's some situations where you don't really know how many bars you really need to extend a signal for, right? So the signal extender is, it's good for when you're trying to connect conditions together, but, condition A only has a limited lifespan before condition B, needs to appear, right? Otherwise, all your indicator conditions kind of fail if condition A is too far away from condition B, right? And so the trade just didn't work out, right? So in that situation, the signal extender is great, because you can say, all right, condition A, is good for whatever, 11 bars, 12 bars, and then condition B needs to happen within that time. Otherwise, the trade setup just kind of falls apart, right? Too much time has elapsed, right? But, with the toggle node, I kind of built this system here to give you an example of when, the number of bars doesn't quite fit in with, what's needed here. Whereas, right, so with this system here, you just want the first signal to come in, and you don't know how long it's going to take to get to the next day, right? It's going to be a lot of bars there to get to the next day, right? Obviously I'm on a 1 minute chart here, so we can count that, but what if you're trading on a range chart or a tick chart, right? You have no idea how many bars it takes to get to the next day. So in that situation, the toggle node is going to kind of work out better here. So yeah, let's see here. Oh, also one other thing to note here is, with this example here, you'll notice the starting state, I actually turned it on. So why, right? Normally, let me put another new toggle node here, right? So the starting state is off by default here. But in this situation, because we're wanting a signal to get through, right? We want the first signal to get through, and we're using the toggle node with an AND node to filter signals here, right? Again, we're using this toggle node in a typically opposite situation here. Since it is preventing signals, then the toggle node needs to start on here. So let's go back to the beginning of the chart here, right? So as soon as the first bar appears on the chart, right, our toggle node is on, right? And so it's on during the overnight session, right? It's on, right, until that first crossover signal occurs, and then the toggle node turns off, right? So you can see that before the crossovers, signals started coming through, right? So before these crossover signals, right, started coming through, the toggle node needed to be on for that first signal there, right? So yeah, let's connect that in, right? So if I take the toggle node and I put it back to off, then it'll just never work. So yeah, you'll see that we won't ever get any signals anywhere. So, right. So looking at the toggle node, we can see the reset. Well, yeah, let's see here. Yeah, the reset turns it on. So eventually, when we get to the next day here, there we go. So when we get to the next day, then a signal gets through here, right? So this is the second day on the chart, right? But if I go to the first day of the chart, here, the first day, the signals don't get through. Let's see, where would it be? There we go. So, yeah, this is when the market opens for my time zone, right? So because the toggle node was not on during the first day, then no signals occurred on the first day. And it wasn't until we got to, right, the end of the trading day that, right, this time-based node here going into the reset did turn the toggle node on there. And so therefore the second day we actually got a signal. Yeah. So let's see here. All right, so I guess, yeah, let me kind of go over all of these settings here. Just, yeah, so we have a technical explanation here. So the signal threshold here, what is that? All right, we see it's set to 0.8. So this goes back to the fuzzy logic mathematics that BloodHound is built on here, right? So if we look at BloodHound's output, right, we have this green line and this red line, right? And the signal, right, the output has to be greater than these threshold values. And we can see they're actually set at 0.8. Yeah, or this one's, right, the short signals are set at negative 0.8. And the positive signals are set at positive 0.8 here, right? So really, I mean, yeah, the practical answer is you don't ever need to touch or mess around with the threshold signals unless you're building a fuzzy logic system here, right? So these crossover signals, you know, a crossover is a crossover. There's no fuzzy logic math here. So, yeah, so there was no need to mess around with the threshold level there. But what that does is if you do have a fuzzy logic built system, you can determine how strong does the signal need to be to turn the toggle node on and off. Right? So since nobody's really using fuzzy logic, I'm not going to go much further into that. So, all right, starting state, pretty self-explanatory, right? The toggle node can either, by default, right, it's going to be off, and then you need a signal coming in to turn it on, right? It could be, right, a signal can go into the input, or it can go into the reset, and the reset could turn it on as well. So we could, you know, we could set it up like this, right? So, or, you know, as I explained earlier in this example, in order to get a signal on the first day of our chart, the toggle node needed to start in an on state. So there we go. So that's pretty self-explanatory. All right. Yeah, and I think the inputs and the reset connections are pretty self-explanatory as well, but let's just go through them real quickly here, right? So the input section here, right, that pertains to the input connection right there, right? So, so you have a signal coming in, and you can determine, is that signal going to turn the toggle node on? Is it going to turn the toggle node off? Are you going to put the toggle node in a toggle basis? Or, you know, is the signal going to do nothing there, right? So, yeah, I guess like another example here might be every once in a while, sometimes you'll want the toggle node turned on when a signal comes in, but you may not want to turn the toggle node off based on the opposite signal. So sometimes you might set this to no action, but then the reset, you'll use the reset to actually turn the toggle node off, right? And that would be, you know, some other condition, you know, this actually isn't a practical example there, but yeah, just to be aware that when you do turn the toggle node on, somewhere in here you need to turn the toggle node off, right? If the toggle node stays on forever, then it's really not doing any good, because, right, if your toggle node is turned on way at the beginning of your chart, then by the time you get to the real-time trading, right, that toggle node is stuck on, and it's not really doing any function anymore. So somewhere within the input and the reset, you do need to have a force off. So yeah, and so sometimes you might use the reset connection only to turn that toggle node off there. Yeah. So this settings like this, right? The default settings are the most common. That's why they're the default settings. And so this example here, what I just showed you, would be probably the second most common setup here. So the input, turning the toggle node on, and then the reset, a reset opposite signal, is turning that toggle node back off. And then I would guess here that the third most common situation is, right, you're using a signal coming in to turn it on, and then you're using the same signal direction, right? So if a long signal comes into the input, right, and it turns the long state on, then sometimes you might use a long signal coming into the reset to then turn the toggle node off. So that's probably the third most common situation there. And then down here, right, this little example here is probably, well, I guess this might be tied for third or fourth, where the input is actually turning the toggle node off, and the reset is turning it on. So it's kind of hard to say if this is the third or the fourth most common, or up here, on signal, force on, and then on signal for the reset, force off. So yeah. All right, and again, each setting here, right, has the same options: force on, force off, toggle, no action, right? So down here for the reset, same thing, right? Force on, force off, toggle, no action, right? So on and so forth, right? So then we kind of get down to the last setting here, the output. Let's see here. Yeah, let's take a look at that. Oh, actually, let me kind of put this back to defaults. There we go. And all right, so the outputs here. So we could kind of reverse everything, right? So if the toggle node is on, right, we're seeing that output. But if the toggle node state is on, we could actually set that to 0, and then let's see here. Actually, what should we do? Actually, let me use yeah, I'm going to use our toggle node down here because it has a bunch of connections here. And so let's reverse this here, right? So we can see right now, right, when the toggle node's on, it had an output. So now let's reverse all that. So now the toggle node's on, right, when the first signal comes in. And actually, remember, when the signal comes in to the input's forcing it off, right? And the opposite's forcing it off as well. But so the toggle node is actually off, but because we reverse the outputs here so that we actually get an output when the toggle node is off, we're actually now seeing something here. So, all right, and there we go. So the toggle node has an output because it's currently turned off, but then, right, we have the reset that turns the toggle node back off right during the overnight session there, right? So, but now the toggle node is off because we just reverse the outputs. So pretty straightforward there, right? Yeah. And we could also do a invert as well. Essentially, you know, reversing those is also now doing the same as an invert as well. So if I enable the invert, boom, we get the same exact results, right? The first signal comes in, turns the toggle node off, right? Turns it off, but now we've inverted it. So now it looks like the toggle node is on. And then during the overnight session, when the toggle node is actually on, the output has been inverted to being on, right? So, so internally, the toggle node is in a on state, but we're inverting the output here, right? So adjusting these outputs or using these modifiers here, right? That's a modification at the output connection, technically, right? So those, you know, who want to understand the technical operations here, right? It's a modification at the output connector, but internally, right, in the code that controls it, the toggle node is actually on, and then it gets reversed right at the output connection there. All right, let's reverse that, and put that, set that back correct. There. All right. There. All right, I'll just give that a name. Yeah, I think that's good enough for the toggle node. Again, it's not that complicated of a node there.